So we're going to go ahead and get started on 1D, one-dimensional kinematics. So things to think about when we start kinematics. These are some just different ways that you might use it. So how can you determine the speed of an object with only your tape measure and stopwatch? What does it really mean to accelerate? Can you have a positive and negative acceleration? Is there a difference between your odometer and speedometer in your car? And can they accurately tell you your velocity? What are vectors? What would hit the ground first? So if you dropped a baseball and a bowling ball from the same height, what would hit the ground first? So that's kind of what we're looking at here with this section. This unit is going to be just looking at those basic one-dimensional kinematics, so motion in one direction. So kinematics is talking about the study of motion. Okay, so it's a study of how your objects are moving. A lot of these examples will be of vehicles because that's the easiest way to describe it. So you know that when you're driving, your speedometer is telling you your car's speed, and that has to do with the amount of time that you've covered, the amount of distance you've covered in a amount of time. So when you're looking at your speedometer and you're driving down the highway, let's say you're driving down 61 and you look down, it says you're going 70 miles per hour. That's an instantaneous speed. Okay, so that's just like a little snapshot of what you're doing at that instant. Your average speed would be different from that. Okay, so just keep that in mind. The instantaneous measurements are not the same as average, and you do need to differentiate between the two. So if you would use your speedometer to look at your instantaneous speed, and that obviously changes as you drive. You might slow down as you get off the exit to come onto school property. Or I hope you slow down. You're not going 70 when you come off the exit. So to find your average speed, you would need to look at the odometer as well. Okay, so you would look at the distance of your total trip, and then divide that by your total time, and you would figure out what was your overall your average speed as you were moving. So your speed is a scalar quantity, and we'll talk about scalars versus vectors. Okay, so speed is a scalar quantity. It's just telling you a value, but it's not telling you in what direction. So I might say, man, I was driving 70 miles an hour down 61 this morning. That's not telling you which direction I was going. It doesn't tell you if I'm going north or south. So speed is just a scalar quantity. Other scalar quantities could be just like a measurement. So, you could say your acceleration was 5 miles per hour. Well, that doesn't tell you anything. That doesn't tell you if you were decelerating or accelerating. It doesn't tell you if you were going left or right, north or south. So a scalar quantity has a magnitude, which means it has a value, but no direction. Okay, so this example says that you're going 100 kilometers per hour for 4 hours. And it tells you it gives you information, but it doesn't tell you where you went. Okay, so I could drive 100 miles tonight and I could end up in a variety of places because I didn't tell you where I was going. So most of the time in physics, you're going to be worried about vectors. You always want to have things labeled very specifically. So I know that if you were in chemistry last year, you're probably used to labeling things pretty well, but you always want to have multiple units. As many units as you can tack onto a value is better in physics because you're giving more specific details. So physicists often will also add the direction on. So whenever you have a value and you add on not only the units it's measured in, but also the direction it's moving in, that's called a vector. Okay, so that's when you're getting into you know more about like the position of things and their displacement, and you can use that information a little bit more than just a scalar quantity. So a vector is going to look like this. You're going to have the magnitude and then the units, and then the direction will be in brackets afterwards. So I might have 5 miles per hour brackets west because it's telling me I'm going 5 miles per hour west. Okay, so another way to show that is that when you're writing your variables that'll be associated with the vectors, that variable is going to have a little arrow over the top of it. Okay, so we call that a vector hat. So one way to think of it, it's kind of a silly way, but you want to think of it this way. So vectors, they're going places, like they have a direction. I'm going to the store, so I'm going to drive 5 miles northwest. So they're going to wear their hat. Okay, so they're going out, they're going somewhere, so they're going to put their hat on. So that's kind of a silly way to think of it, but that's one way to remember that. So vectors have arrows or little vector hats on them, so that it denotes that it not only has a value, but it's also going in a specific direction. Okay, so this is how something would need to be written out. You could say that the vector, the velocity vector here, so V is for velocity, your little hat tells you that it's a vector, it has a direction associated with it. You'd have your value, the magnitude is 4.2, the units are meters per second, and the direction is east. So lots of different kinds of vectors in physics. It really helps you get a more specific idea of where things are going, where things might land, things like that. So you can actually associate a vector or a direction with position, displacement, velocity, momentum, force, acceleration. So in this unit in particular, we're just going to be really focusing on one-dimensional motion. So we're going to be talking about position, displacement, velocity, and acceleration. So here's some more examples of that, okay? So position and displacement are some vocab words that you want to be familiar with, okay? So your position is talking about your location or the object's location relative to some reference point, okay? So let's say that here your flag on this scale is where this person is starting, and they walked 5 meters east, right? So their position, D, is going to show the distance that something has been displaced. So their position is D with a little vector hat on top, because we're going to show not only the magnitude, but also the direction. So his position is going to be 5 meters east of whatever reference point you're starting at. So very basic sample. So he's 5 meters east of the beginning point, the 0. So displacement is a little different, okay? So displacement is indicating that there was a change in position. So position is just saying, like, okay, you live 1 mile north of Walmart in town. So that would be your position. But your displacement would be a change in that position. So the delta, this little triangle, is called a delta if you're not familiar. A delta in front of anything is indicating a change in that. So you have a change in your position of 2 meters east. So we knew that this person in blue here, his original position was 5 meters east. Now he has moved an additional 2 meters to the east. Okay, so if you live 1 mile north of Walmart and that's your position, and then you drive to school, you have had a change in position, a delta D, a change in position of, 5 miles east, okay? So that would be your displacement. So we're going to have a little example here. So this street is supposed to help us look at different positions and distances and kind of just get a better idea of examples of that. So we have a cinema, so a movie theater, a post office, and a bakery. It shows you some distances between these here. So if you leave the movie theater, okay, after watching a movie, what is your initial position? So if you leave this movie theater and you're right here, your initial position is going to be 0 meters because you haven't gone anywhere else. Okay, so your initial position was here at the movie theater. Your position, represented by D with a little hat, is going to be 0 meters. And since you have not moved, and this is the initial position, there's no direction associated with that. Now, if you look at distance, how far have you traveled? You haven't traveled anywhere because you're still here. You're standing outside the movie theater, okay? Now let's change that. We walk to the post office, okay? So we're moving from the movie theater to the post office. What's your new position? Okay, so our new position here is going to be 23.4 meters east because our initial position, our reference point, is going to be in front of the movie theater. We moved 23.4 meters to the east of that reference point. What is the total distance that we've traveled? It is also 23.4 meters. Okay, so note the difference here in the way that these are labeled. So the position tells you what direction you have gone in. It has a little vector hat, a little arrow over the top because it's we know that that value is going to give you also the direction. The distance is just a magnitude. Okay, so a distance is a scalar quantity. It's saying that you have traveled this far. It doesn't give you any other information. So let's continue our walk. Let's say we walked from the movie theater to the post office, and now we're walking back to the movie theater. So if we move back to the movie theater, what's your new position? Well, our new position is now 0 because that's where we started. Okay, so the position is back to 0, back to our initial reference point. But our total distance that we've traveled is going to include the distance that you covered going to the post office and back. Okay, so the distance, again, is just a scalar quantity, is just a magnitude, a number. So we've covered now 46.8 meters because we have walked to the post office and back to the movie theater. Then we're going to go ahead and go back down to the bakery. Okay, so you and your friends are indecisive tonight. So what's our new position? So if we walked from the movie theater all the way down to the bakery, our new position is going to be this total distance here in the direction that we moved. Okay, so we had 23.4 meters plus 37.7 meters to the east. So we have a total displacement basically in this walk. Our new position is 61.1 meters east. Okay, so we have the hat over here showing direction. Oops. And then we have our value, the unit, and the direction that's included here because we went east. So what total distance have we traveled? Okay, now our total distance walking is 107.9 meters. Because if you remember, we started at the movie theater, we walked to the post office, and then we walked back to the movie theater, and now we walked all the way down to the bakery. So we're accounting for that total distance that we've traveled. Okay, so your distance now that you've covered is 107.9 meters. Okay, so just remember that position is going to be relative to your reference point. So in this case, our reference point was the movie theater. So anytime we were at the movie theater, our position was 0. And then and then your displacement has to do more with the distance that you've covered, okay? So if you went out to the track and you decided you were going to run a mile, okay? So you ran a mile. You're going around and around and around that track, and you obviously are covering distance. You've covered a mile in distance, but if you stop in the same place you started, your position would still be 0. Okay, so your position would be 0 meters because you are ending up where you began, but your displacement obviously would have been a mile because that's the total that you ran. So here's a different example of that. So another street scene, we're going to look at the difference between distance, position, and displacement again. So this time our reference point is going to be the post office. So we're going to start out right here in the middle. So we exit the movie theater after watching a movie. What is our position? Okay, it's not 0 this time because our reference point is the post office. So the distance between the post office to the cinema and the direction would be our new position. Okay, so our new position is going to be 23.4 meters west because our reference point was the post office, and we are now 23.4 meters to the west of that point. The total distance that we've traveled so far is going to be 0 meters. Okay, so we are coming out of the movie theater. We haven't walked anywhere, so our distance is 0 meters, even though our reference point's over here. So now we're going to go from the movie theater to the post office. So we're walking to the post office. What's your new position? Okay, since the post office is our reference point, our new position is 0 meters because we're returning to the reference point. Okay, the new displacement is going to be 23.4 meters east because you are now displaced from your original position of the movie theater. You walked 23.4 meters east to the post office. So that's your displacement. And then the total distance that you traveled is also 23.4 meters. Okay, so note the difference here. So your displacement in this case is going to give you a direction and a measurement, and then your distance is just the scalar quantity. So displacement is a vector quantity because it gives you the value, the magnitude, and the direction, and then the distance is just a scalar quantity because it just gives you the magnitude. So we keep on walking. Now we go from the post office back to the movie theater. What's our new position? The position relative to the post office, because that's what this problem was talking about. Now we're relative to the post office. We go back to the movie theater. Our position, again, is 23.4 meters west, because that's how far away we are from our reference point to the west. My displacement is back to 0, okay, because we started at the movie theater. Even though the reference point is the post office, we began at the movie theater. So your total displacement right now is 0, because you're ending up right where you started. What is the total distance you've traveled? Well, now your distance is going to be 46.8 meters, because you have gone from the movie theater to the post office and back to the movie theater. Well, let's go all the way down to the bakery. Another example here. So what's your new position? Now my position in relative to the post office is going to be 37.7 meters east, okay, because the reference point was here. Now we walk 37.7 meters to the east. My displacement, my total displacement from where I began, because I began at the movie theater, is going to be 61.1 meters east. Okay, because that's this entire length. Because I started here at the movie theater, and now my displacement from that position is over here. The total distance I've traveled is 107.9 meters. Okay, so you started at the movie theater, you went to the post office, you came back to the movie theater, and you went to the bakery. So it's the same path that we followed before. The only difference is that the reference point on this set of examples is the post office, where the first example that we went over, the reference point was the cinema. So the difference there is basically going to be in your displacement in your position. So that's where we got those different numbers from. All right, so we're walking back to the movie theater. My new position is, again, 23.4 meters west. Okay, so I'm here. My reference point is here, the post office. So I go back here. My new position is 23.4 meters west of my reference point. My displacement is 0 again, because this is actually where I started, was the movie theater. And the total distance I've traveled now has been from the movie theater to the post office, back to the movie theater, to the bakery, and back to the movie theater. So now I have a total distance of 169 meters. Okay, so we just want to remember that displacement is your change in position. Okay, so when your starting position and your ending position are exactly the same, your displacement is 0. So if you walked in a circle around your room, your displacement is 0. That doesn't mean your distance is 0. You just are displaced 0 meters from where you began. Okay, so that's all we're going to go over for today. We're just talking about again, know the difference between a scalar and a vector quantity. So scalars are values with no direction, and vectors are values with a direction. Know the difference between position and displacement and distance. And that is it. So I hope that this was an easy lesson for you. We'll get into acceleration and velocity a little bit more next class. So you can find your assignment under the assignment tab, and please contact me if you have any questions.